Section 4 of this. Section 4, page 6. Okay, so we're going to try to figure out this limits and what it means. So we gotta show our work, so this is going to take a bit longer than usual. Okay, so let's start this. So the limit of x approaching 3 just means we gotta apply this limit of all x's that are in this function. So let's rewrite this function. Since this is an x and this has an x, we have to evaluate this. Since this means it's going to be negative of negative 3 of 3 plus 2 of negative 3 squared minus 4. This does not be affected since it does not have an x. Not affected. Okay. This would equal 3, 9, 27 equal negative 27 plus 9 minus 4, which equal 27 plus 18 minus 4, which is 41. There you go. Okay, this one looks a bit more complicated, but in reality, it's pretty much the same. Okay, so we gotta redo the same thing. So we gotta do the limit of x approaching pi over 6 of, well, let's rewrite the sign, secant as 1 over cosine of x, of 1 over cosine of x times sine over x of cosine over x. Since this just makes it a bit easier and more visual to see. So right now we just have to evaluate these at pi over 6. So we have this equals 1 over cosine of pi over 6 times sine of pi over 6 over cosine of pi over 6. Pi over 6. Okay, so we know that cosine, let me write a quick visual, 1, 2, 3, 3, 2, 1, divide everything by 1/2 pretty much, root everything besides 1, this is cosine, sine, pi 3, 4, and 6. And so what we can see here is this is going to be this is going to be 1 over cosine of pi over 6 is going to be root 3 over 2 times sine of pi 6 is going to be 1/2 times 1/2 times cosine of pi 6 is going to be 3 over 2. We can rewrite this 3 root 3 times 1/2 times 2 over root 3. This 2 are going to cancel out, and this is all just going to leave me 2 of 3. Therefore, the answer is going to be 2 over 3. Okay, pretty simple. Okay, this limit problem right here, it's going to be a bit more harder, but it's pretty easy after you see it. So let's start it out. Since we know we can't right away solve this, since if we plug it in, we're going to get 0 over 0. So we got to do something different. We're going to find the conjugate. Conjugate is just times in the reciprocal of the denominator. Which, let me do that real quick. Of x approaching root 9 minus x plus 9 times 9 plus x plus 9 over 9 plus x plus 9. Which this will equal the limit of x approaching 0 of x of root 9 plus x plus 9 all over 9 minus x plus 9. Okay, since these cancel out, this cancels out, makes everything sense. And then we can go a bit further in and then realize if we distribute this, we're going to get, ooh, that looks ugly. If we distribute this, we realize we can get rid of the 9s. So let's do that. X approaching 9 plus, okay, that's a bit too big, plus x plus 9 over x, negative x. And so if we distribute this, there we go. And then we can get rid of the x's as well. The limit of x approaching 0, I forgot my parentheses right here, 9 plus x plus 9 all over negative 1. Now we can evaluate the limit as x approaching 0. So this would equal of root 9 plus root 9 over negative 1, which is 3 plus 3 over negative 1, which equals negative 6. There we go. That'll be it. Oh, never mind, we have a couple more problems. Okay. Let's do problem 4. Okay. Is this going to be section 5? Okay, let's do this one. Limit. This one looks a bit complicated, but it's not as complicated. Since we can see this is 0, 0, since this would be 1 minus 4, this would be 4 minus 4, therefore it's going to be 0 over 0. We can easily see this. Something we can do is just times this by the reciprocal, or not reciprocal, times it by the common denominator. So let me show you. This would equal 4 minus x over 4x. We just have to times this by this. Okay, and then we get 4x all over the same thing of x minus 4 over 1. We give the limit of x approaching 4 of 4 minus x all over 4x times 1 over x minus 4, which would equal the limit of x approaching to 4 of x minus 4 of 4x, and since we could times this by negative, and this will equal positive, this will be the same thing. So we can do that, times it by negative of 1x minus 4. Since the 4 would be positive, the x would be negative, and we can cancel these out. This will leave us with the limit of x approaching 4 of negative 1 over 4x. Then we can evaluate the limit, which equals negative 1 of 4 times 4, which equals 1 over 16. Okay, let's do one more problem. 2 more problems, actually. Okay, the limit of x approaching negative 2 of x plus 2 over x squared minus x minus 6x. Since if we plug this in, we're going to get negative 2 plus 2, which is already going to give us 0, which is a bad start. And 4 minus 2 minus 6, which is also 0, which is 0 over 0. We have to do something different. Something that I see right away is x plus 2. I know that that's going to be a factorable from here. So let's rewrite this limit. Limit as x approaching 2 from x plus 2 of x minus 3. Okay, so let me do this problem. The limit of x approaching negative 2 is going to be x plus 2 of x plus 2 of x minus 3. This will give me something crossed out, which is the limit of x approaching negative 2 of 1 over x minus 3. And we can now evaluate this limit as 1 approaching negative 2 and 3. Therefore, we can get an easy number, which is 1 over negative 5. There we go. Pretty simple. Concept is find something that you can cancel out, then you can find it. Okay, 6. This is pretty much exactly what we just did, but in a different format. So however, this is from the right. So this is completely the same, but just a bit differently visually. Okay, let's see what happens if we plug this in. So it'll be 3 plus 2, which is 5. So it'll be 9 minus 3 minus 6, which equals 0, which is 5 over 0, which gives us 0. So we can't do anything quite yet, because you can't divide anything by 0. The limit of x approaching 3 positive from the right of x equals 2. We know that we can have something out, since this would equal x squared plus 2x minus 3x minus 6. And this would give us x squared minus x minus 6. So that checks out. I always like to check it out if I don't not know 100% sure. This would equal, we can cross out this, which would equal the limit of x approaching 3 from positive of 1 of x minus 3. And we can plus positive. Okay. Which would now evaluate from plus 3. Keep in mind, plus 3 means it's going to be like 3,001. It's always going to be slightly bigger than the 3 actual value. So this is going to be like 3.001 minus 3, which in turn is 1 over 0.001, which is going to be very, very big, which is infinity. Positive infinity. We can't make that confusion. Okay. And that would be all for this. Okay. Thank you.